In this episode, we shift from thinking about individual values to thinking about structured data, because automation rarely succeeds when it treats the world as a pile of disconnected strings. Modern operations work depends on services talking to each other, and those services need a shared way to describe settings, events, and results in a form that software can reliably read. That is where JavaScript Object Notation, JSON, shows up, because it is a simple, widely used format for representing structured data as text while still preserving meaningful structure. Beginners often feel intimidated by JSON because it uses braces, brackets, and nesting, and it can look like a dense wall of punctuation at first glance. The truth is that once you learn how to read its shapes and rules, it becomes one of the most predictable parts of an automation workflow. Confidence with JSON is really confidence in your ability to move data between systems without losing meaning or creating silent mistakes. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful starting point is to understand what problem JSON solves in everyday operational terms. Systems need to exchange data in a way that is both human-readable and machine-parsable, meaning a person can inspect it, but a script can also interpret it without guesswork. Plain text messages can be read by humans, but they are often ambiguous for automation because small formatting differences can break parsing. JSON reduces that ambiguity by representing data as a set of name and value pairs and ordered collections, which gives your automation predictable places to look for the information it needs. In automation pipelines, this predictability matters because it turns complex responses into structured inputs for the next step. When the next step expects a field called status or an array of items called resources, JSON provides a stable map rather than a vague sentence. This is one reason cloud services and automation platforms rely on it so heavily, because it supports reliable integration at scale. To work confidently with JSON, you need to recognize its two core shapes and how they behave. One shape is the object, which is a collection of key-value pairs where each key is a name and each value can be a primitive, another object, or a list. The other shape is the array, which is an ordered list of values, and those values can also be primitives, objects, or even arrays. When you see braces, you should think object, and when you see brackets, you should think array, because those shapes tell you how you must access the data. A beginner misunderstanding is treating everything like a flat dictionary of values, but real JSON often nests, meaning values contain other structured values. Nesting is not there to be annoying, because it mirrors how real entities are built, like a resource that has metadata, settings, and a status section. Once you read the shape, you stop feeling lost, because you always know whether you are looking up by name or stepping through a list by position. Keys and values are where meaning lives, so confidence also depends on understanding what keys represent and what values can be. A key is a name that identifies a field, such as region, ID, enabled, or tags, and it is how the producer and consumer agree on what a piece of data means. A value can be a string, number, boolean, null, object, or array, and that type matters because it determines how your automation should interpret the value. A beginner often assumes everything is a string because JSON is text, but the whole point is that it can represent types explicitly inside the structure. When you treat a boolean like a string, you risk logic bugs where a non-empty text value behaves as true even when its meaning is false. When you treat a number like text, you risk incorrect comparisons and threshold checks. Working confidently with JSON means you respect the type of each value, and you design your logic around that type rather than around how it looks when printed. One of the best ways to reduce mistakes is to develop a habit of mentally walking a path through the structure before you try to act on it. When you see nested objects and arrays, imagine the access steps as a route, like starting at the root object, then entering a field, then selecting an item from an array, then reading a nested field. This mental path helps you avoid a common beginner error, which is grabbing the wrong field from the wrong level because names repeat in different parts of the structure. For example, many responses contain an ID at multiple levels, like an account ID and a resource ID, and confusing them can cause your automation to target the wrong entity. The operator mindset is to treat structure as context, meaning the same key name can mean different things depending on where it lives. If you can clearly describe the path to a value, you are less likely to misinterpret it. This also makes troubleshooting easier, because when a value is missing, you can pinpoint exactly which part of the structure did not match your expectations. Validation is where JSON becomes a safety tool rather than just a data container, because safe automation does not trust input blindly. Even when the data comes from a trusted service, it can be incomplete due to errors, version changes, permission issues, or partial responses. A fail-safe approach validates that the expected keys exist, that the values have the expected types, and that the values are within reasonable bounds before making decisions or changes. Beginners sometimes validate by checking only that a field is present, but presence without type correctness can still cause silent failures. For example, a numeric field might arrive as a string in some edge case, or a list might be empty when you assumed it would contain at least one item. Validation should also consider optional fields, because optional does not mean irrelevant. It means you must handle both cases predictably. When you validate early and consistently, JSON becomes a reliable interface instead of a source of surprises. A related concept is schema, which is the idea that structured data usually follows a defined shape even when you do not have a formal schema document in front of you. In operations, you often learn a schema by observing examples, reading documentation, or inspecting responses, and then you build your automation around that expected structure. The risk is that schemas evolve, and when they do, your automation can break or misbehave if it assumes a field will always exist or will always be of one type. A confident approach is to design with graceful handling of missing or extra fields, because extra fields should not break your logic and missing fields should trigger safe behavior. This does not mean your automation should accept anything, because acceptance without understanding is dangerous, but it does mean you should detect changes and respond predictably. In many workflows, the safest response to a schema mismatch is to stop and surface the issue clearly rather than proceeding with partial information. This is how you prevent silent drift in pipelines that depend on consistent structure. It also helps to understand that arrays introduce a different kind of risk than objects, because arrays are about order and multiplicity. An array often represents multiple items, like a list of results, and automation must decide how to handle 0 items, 1 item, or many items. A beginner mistake is to assume an array will always have at least one element, and then build logic that fails or behaves strangely when the array is empty. Another risk is assuming the order is meaningful when it might not be, because some services do not guarantee ordering unless explicitly stated. If your automation relies on the first item being the newest or the best match, you may get inconsistent behavior across runs. A safer pattern is to select items based on properties, like choosing the item whose ID matches a known value or whose status meets a condition, rather than by position. When you treat arrays as sets of candidates rather than as fixed-order lists, you reduce fragile assumptions. This mindset is a big part of confident JSON handling because it keeps your automation stable when the real world does what it always does and changes. Nested structures are where confidence is tested because nesting is powerful and also easy to misread when you are moving fast. A nested object can represent a related concept, like metadata inside a resource, and nesting can go multiple levels deep, especially in responses that include configuration, state, and history. The operator approach is to slow down just enough to identify the boundary between each level, because each boundary is a point where missing data or unexpected types can appear. Beginners often try to jump directly to the value they want without confirming the intermediate levels exist, which can cause errors or, worse, cause fallback behavior that hides the problem. A safer approach is to treat each level as something you confirm before proceeding, especially when the automation will take an action based on the value. This approach connects directly to fail-safe conditionals, because each level check becomes a gate that protects downstream logic. When your automation treats nesting as a sequence of verified steps, you reduce the chance that one missing piece causes a wrong decision. JSON also forces you to think carefully about null, because null is a real value that means intentionally absent rather than simply missing. A field might exist with a null value to signal that the producer knows the field but does not have a value for it in this case. That is different from the field not appearing at all, which might mean the producer does not support the field or did not include it due to a different response mode. Automation that treats null and missing as the same can make incorrect assumptions, such as assuming a configuration was never set when it was set to an empty state intentionally. In operations pipelines, null can also be used as a placeholder for values that are resolved later, which means your automation must decide whether to wait, to retry, or to stop. The fail-safe principle applies here as well, because actions based on null values should be conservative. When you can clearly explain what null means in your context, your pipeline becomes easier to reason about. Confidence comes from knowing the difference between absent, empty, and intentionally null, and treating each case deliberately. Another important skill is recognizing where JSON boundaries appear in a workflow, because many problems happen at boundaries rather than inside the structure itself. A boundary occurs when a structured object is converted into text for transport, stored somewhere, or passed into another tool or stage that might not preserve types perfectly. If your pipeline flattens structured data into plain text too early, you can lose type information and then make decisions based on strings that look like numbers or booleans. This is where silent failures often begin, because later stages might do comparisons or conditionals incorrectly without crashing. A confident pipeline design preserves structure as long as possible, only converting to simpler representations when there is a clear reason. When conversion is necessary, the safe approach is to validate the structure again after conversion, because conversion can introduce formatting changes or encoding issues. Thinking in terms of boundaries helps you place checks in the right places, which reduces debugging time when something goes wrong. Security and safety concerns show up in JSON work more often than beginners expect, because structured data frequently includes sensitive configuration and identity-related fields. In a cloud environment, JSON can contain resource identifiers, access settings, policy statements, and operational metadata that should not be casually trusted or casually logged. Confidence includes knowing that structured data can be manipulated, whether by an attacker in some contexts or by a misbehaving upstream system. So validation is not just about correctness, it is also about safety. If your automation trusts a field that identifies a target resource without validating it against expected patterns or allowed sets, you can accidentally act on something you did not intend to touch. If your automation logs entire objects without filtering, you might expose secrets or sensitive values in logs, which creates a different kind of incident. A professional approach is to treat JSON as data with meaning and risk, not just data with convenience. When you handle it carefully, you make both your automation and your environment safer. It is also worth addressing a beginner misconception that JSON is always clean and consistent because it looks structured. In reality, producers can be inconsistent, fields can change names across versions, and arrays can include mixed types when you assumed uniformity. Some producers include fields only when certain conditions are met, which can make your automation behave differently based on environment or permissions. Confidence is not believing the data will always be perfect, because confidence is having a plan when it is not. That plan includes checking for required fields, treating unknown fields as ignorable unless they matter, and treating unexpected types as a reason to stop and investigate. It also includes being careful about optional fields that you might want to use for optimization, but do not want to depend on for correctness. When you design with these realities in mind, your pipelines become resilient. Resilience is what prevents small upstream changes from becoming downstream failures that are hard to trace. When you connect JSON handling to other automation fundamentals, you start to see how everything fits together. Primitive data types matter because JSON values are typed, and those types drive safe comparisons and safe decisions. Conditionals matter because you use them to validate structure and to choose safe paths when the structure is incomplete or unexpected. Iteration matters because arrays often require you to process multiple items safely without assuming order or presence. Parameters matter because you might choose different keys or filters based on environment, and those choices should be explicit rather than hidden. Functions matter because parsing, validation, and extraction logic should be encapsulated so it is consistent across a script or pipeline. This is why confidence with JSON is not an isolated skill, because it sits at the intersection of reliability, safety, and integration. If you can reason about typed nested structures, you can reason about modern automation workflows with far less stress and far fewer surprises. As you pull this together, the key to working confidently with JSON is to treat structure as a contract, to treat types as meaning, and to treat validation as a safety gate rather than as an optional improvement. When you read the shapes correctly, handle arrays and nesting deliberately, and distinguish missing from null, you prevent a large class of silent automation failures. When you preserve structure across boundaries and recheck assumptions where conversions happen, you protect pipelines from subtle drift and inconsistent behavior across environments. When you think about security implications, like trusting targets and avoiding unnecessary exposure in logs, you keep automation aligned with operational responsibility. On exam day, the strongest answers in this area usually reflect careful handling of structure, explicit validation, and conservative behavior when the data does not match expectations. In real operations, the same habits reduce incidents and reduce the time you spend debugging under pressure. If you build these habits now, JSON stops looking like punctuation and starts looking like a dependable map, which is exactly what automation needs.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.